Hello everyone. Okay, this will be the last lesson that we'll be doing over the extended curriculum. So please take out your notes on metals 13A and turn to this section on the reactivity series. Okay, Mrs. Go have already gone through the first parts of the metals chapter, and I shall be carrying on from there. Alright, so for this section, okay, we are going to learn to place in order of reactivity these following metals, okay, and then refer to their reactions with water, steam, and dilute hydrochloric acid. And also from like experimental results, okay, you are to determine which metals are more reactive versus other metals. Alright, so there are many kinds of metals, okay, in the world, okay, and they can differ in their chemical reactivity. Right, so when we arrange the metals in order of chemical reactivity, okay, we call it a reactivity series. Right, so these are the list of metals that you all need to know, okay, and what is their reactivity. All right, and of course there are many more metals than the ones listed below, but these are the ones that you will be learning about. All right, so let's see. Okay, we have potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, copper, silver, gold. All right, so this whole list of metals, okay, potassium is the most reactive. Okay, as you go down, they become less and less reactive. Okay, and gold is the least reactive metal. Okay, and coincidentally, because gold is the least reactive metal, okay, it doesn't rust, it doesn't react with acids, okay, it doesn't tarnish. Okay, that's why it's quite a expensive metal, okay, because it's so unreactive that it can maintain its form. All right, on the other hand, okay, potassium is so reactive, and if you remember from the periodic table chapter, okay, it's so reactive it can quickly react with the air, okay, and it tarnishes quite quickly. All right, so we have a whole list of metals here, and you are to remember which one is more reactive than the other. All right, so that's why I've come up with a mnemonic. Okay, mnemonic is a way to remember things. Okay, example, how do you remember the 7 colors of the rainbow? Okay, red, orange, yellow, green, indigo, violet. All right, so for me, I remember it as Roy G. Biff. Okay, I don't know what for you guys lah. Okay, but that's a mnemonic, Roy G. Biff. So the mnemonic, okay, for all these things, okay, you might come across with many different mnemonics, okay, in other books, or maybe you ask your friends from other schools, okay, but this is the one, okay, that I learned and I'll be teaching to you guys. Okay, so potassium, sodium, calcium, magnesium, aluminum, zinc, iron, tin, lead, hydrogen, copper, silver, gold. Okay, you ready? Okay. Popeye sailor can make a zoo in the land having cute small gorilla. Okay. Once again, Popeye sailor can make a zoo in the land having cute small gorilla. So I'll write it down. Popeye sailor can make a zoo in the land, okay, having cute small gorilla. Okay, all right. Okay, I particularly like this mnemonic because it tells a complete story. Okay, I've heard other mnemonics where yeah, it doesn't quite tell one cohesive story lah. So Popeye sailor can make a zoo in the land having cute small gorilla. Okay, things to take note. Okay, there are two metals that start with S. Okay, sodium and silver, and also two metals that start with C, calcium and copper. Okay, so you need to know which letters stand for which one. All right, so if there's anything for you to remember, okay, for this lesson is this reactivity series. Okay, all right, then you would know that potassium is the most reactive, gold is the least reactive. Then add everything else in between. Okay, calcium is more reactive than iron, for example. Zinc is more reactive than copper. All right. Okay. Next. Okay, why is hydrogen included in this reactivity series for metals? All right. Okay. Yeah. So basically, as you know, metals can react with acids. Okay, but not all metals can react with acids. And if you remember, acids have the hydrogen ion. Okay, when they dissolve in water. So they put hydrogen here to kind of represent acids. And metals that are above hydrogen can react with acids, and metals that are below hydrogen cannot react with acids. Right, yeah, that's just a convention that they decided to use. Okay, so metals above hydrogen can react with acids. Metals below hydrogen cannot react with acids. All right, so okay, although hydrogen is not a metal, okay, it's included here, okay, so that we can remember which metals can react with acids and which metals cannot. All right, next we shall talk about the metals in the reactivity series and how they react with cold water, steam, and acid. All right, we shall also talk about the method of extraction. Okay, I decided to summarize all of the reactions in this table. Okay, because it will be easier that way lah. Yeah. Okay, and so once again, this is the reactivity series. Okay, that we just went through just now. Okay, potassium is the most reactive, followed by sodium, calcium, and so on until gold. Okay, and gold is the least reactive of the metals here. All right. Okay, so as you have learned, okay, some group 1 metals, okay, can react quite readily with water, and some of them will even react explosively with water. Right, and potassium and sodium are group 1 metals. All right, so how do I describe their reaction with water? So potassium, you can write there, reacts vigorously. Okay, and for sodium, okay, since sodium is slightly less reactive than potassium, okay, what do you think the adjective would be? Okay, it reacts quickly. Okay, all right, next. For calcium, okay, calcium and magnesium are group 2 metals, okay, but they can react with cold water also, okay, but not as vigorously or quickly as the group 1 metals. Calcium, you can write there, reacts readily, and magnesium reacts slowly with cold water. Oh yes, I forgot. Okay, all right. Okay, all right. Before I carry on, okay, can you cancel aluminium? Okay, yeah, aluminium is actually not in your syllabus. Okay, but it will help in the mnemonic. Okay, it can make a zoo in the land. All right. Okay, aluminium has some weird properties. Okay, if you learn about it. Okay, but we will not be going through that now. Okay, so these 4 metals, okay, can react with cold water, and since the reactivity decreases down the group, okay, and magnesium is already reacting quite slowly with cold water, okay, the rest below, okay, do not react with cold water. All right, so only the first 4, okay, can react with cold water, while the rest do not react. All right, and okay, so when there is a reaction with water, okay, this is the general equation. Okay, metal plus water. Okay, all right, you will get metal hydroxide, okay, plus hydrogen gas. Okay, so example, let's take sodium reacting with water. Okay, you get sodium hydroxide and hydrogen. Okay, as you have learned, okay, from the group 1 metals in the periodic table, okay, when they react with water, they produce an alkali and hydrogen gas. Right, so if a metal reacts with water, you'll get metal hydroxide and hydrogen. Okay, next. Okay, steam. All right. Okay, steam. Okay, steam is actually still water. Okay, but all right, at boiling point. Okay, at boiling point, gaseous state. All right, so when water is boiled, okay, and it becomes the gaseous state, all right, we call it steam. And what do you think is more reactive, cold water or steam? All right, yes, so since steam is water at boiling point, okay, it can actually react with more metals, okay, than just cold water. All right, but since, okay, potassium already reacts vigorously with cold water, what do you think will happen when you react potassium with steam, which is water at boiling point? Okay, you expect it to react even more vigorously. Okay, so maybe I can write there, reacts explosively. Okay, and then as it goes down, okay, reacts vigorously. Okay, then you can write there, reacts quickly for calcium. Okay, and for the rest, okay, actually you can write to iron, okay, reacts readily. And for tin, reacts slowly. Alright, so once again, okay, steam, okay, because it's water at boiling point, okay, it can react with more metals. Alright, okay, all the way up to tin. Since tin already reacts slowly, okay, those below it do not react. Alright, okay, so quite similar to the reaction with water. Okay, when metal reacts with steam, okay, instead of getting metal hydroxide, okay, you get the base, which is metal oxide and hydrogen gas. Okay, so example, let's say magnesium. Okay, magnesium react with steam. Okay, you get magnesium oxide. Okay, and hydrogen gas. Okay, alright, so if the metal reacts with cold water, you get the hydroxide. If the metal reacts with steam, you get the oxide. Okay, and both of them produces hydrogen gas. All right, next. Okay, reaction with acid. Okay, let me fold the paper for a bit so we can do a comparison. Okay, so reaction with acid. Oh, all right. Okay, so it's actually quite similar to the reaction with steam. All right, so it reacts explosively. Okay, with potassium. By the way, it can be any acid: nitric acid, hydrochloric acid, sulfuric acid. Okay, they will react explosively with sodium. Okay, reacts vigorously with sodium. Okay, reacts quickly with calcium. Okay, and same thing. Okay, reacts readily. Okay, with the other metals. And 14 reacts slowly. All right, and okay, there's something. Okay, do not react. Okay, for lead, okay, it actually reacts very slowly with hydrogen. Okay, so slow in fact that sometimes people even say that it is unreactive. Okay, with acids. Oh, I say again, sorry. Lead reacts very slowly with acid. Okay, such that sometimes people even say that it does not react with acid. Okay, because it's so slow. Okay, so you can maybe write there, reacts very slowly. Okay, because as you have learned, okay, if it's above hydrogen, okay, it can react with acid. Okay, just that because it's so close to hydrogen, okay, its reaction is so slow. And those below, okay, hydrogen do not react with acids. All right. Okay, can you tell me, okay, from the acid base chapter, okay, when metals react with acids, what do you get? Okay, all right, you will get a salt and hydrogen gas. So example, let me use zinc. Okay, zinc plus nitric acid, for example. Okay, you get, okay, zinc nitrate and hydrogen gas. All right. Okay, so these are the three reactions of metals, okay, with water, steam, and acid. Okay, as you can see, all of them, okay, will produce hydrogen. Okay, but okay, if it is water, you get the hydroxide. Okay, if it is the steam, okay, you get the oxide. Okay, and if it is acid, okay, you get the salt. All right. Okay, so this is quite a bit of information to process. Okay, but something that you can take note of is the top three are the ones that can react with everything, while the bottom three, and sometimes you can even say the bottom four, including lead, okay, not counting hydrogen, the bottom four metals, okay, do not react with either cold water, steam, or acid. Alright, so that's why sometimes, okay, I like to say, okay, this, I like to separate, okay, the reactivity series to the top three metals, okay, and okay, the bottom four. Okay, the top three metals can react with all three: water, steam, and acid. The bottom four does not react with any of them: water, steam, or acid. Okay, and the middle, the middle metals, they do not react with cold water, but they react with steam and acid. Alright, so that's one more way for you to remember which metals can react with which substances. Alright, and once again, you also need to know what are the products, okay, that can come out from the reactions. Remember that all of them will produce hydrogen, okay, but the second product, in this case, if it's water, you'll get metal hydroxide. If it's steam, you get oxide. And if it's acid, you get the salt. Alright, okay, one last thing. Alright, method of extraction. Okay, extraction is obtaining the metal from its ore. Okay, ore. Okay, the ore is a mineral rock. Okay, metals do not exist as pure metals. Okay, when we find it in the ground. Okay, it actually exists as a rock mixed with metals. Okay, and so you need to extract it. Okay, you need to obtain the metal from this rock, and the way you obtain these metals, okay, is related to the reactivity series. Okay, the more reactive ones, okay, require a stronger method to extract the metal than the less reactive ones. All right, so okay, I'll talk about the less reactive metals first. Okay, all right, let me fold the paper again. All right, okay. All right, as I said, gold is the least reactive metal. Okay, most metals, okay, will be found in ores, or you can say it's like rock. Oh, sorry. Okay, rock plus metal. Okay, so the metal reacts, okay, inside the rock. Okay, and you need to get out. Okay, you need to extract the metal from the rock. Okay, to get the metal itself. Right, so gold is so unreactive. Okay, it doesn't even react with rock or anything. Okay, in the elements, such that okay, gold can be found uncombined. Okay, naturally. Oh, sorry, naturally. Okay, yeah, gold. Okay, if you dig underground, okay, and you find gold, okay, that is gold uncombined with any rock or any elements. Okay, it can be combined. It can be found on its own naturally. All right. For the less reactive metals, okay, the way to extract them from their ores, okay, is to okay, all right, reduction with carbon. Just know that okay, you can add carbon, okay, with the ore, okay, heat them up, okay, then the metals can come up. Okay, so that's what the reduction with carbon means. Okay, you can add carbon to the rock, okay, and you heat them up, okay, and all the metals will come up. Okay, and we will actually learn a bit more, okay, the process of extracting iron, okay, in the next section of the metals topic. Okay, right, so gold can be found naturally. Okay, for these metals, okay, you can simply add carbon. Carbon is like coal, okay, your charcoal, okay, that you use for barbecue. Okay, all right, you can heat up, okay, the rock or the ore containing these metals, and the metals will come up. and then you can extract them. Okay, how about the very reactive metals? Okay, all right, for these metals, okay, they require this method called electrolysis. Okay, and can you write there? Cannot be reduced with carbon. Okay, all right, you cannot use a simpler method of just adding carbon, okay, to the rock and then heating it up to get these metals. Okay, you require this quite complex method called the electrolysis. Okay, it involves heating the ore into high temperatures and passing electricity through the mixture and then separating it, okay, from the cathode and anode. Okay, quite a complex process. All right, so the more reactive metals, okay, to extract them from their ore, okay, they require electrolysis. Okay, the less reactive ones, you can do reduction with carbon. And finally, gold, okay, can be found uncombined naturally. All right, so as you can see, okay, the reactivity series is actually quite a useful series. Okay, from the reactivity series, you can derive, okay, how they react, okay, with cold water, steam and acid, and also how you can extract them, okay, from their ore. Okay, all right, okay, that's quite a lot to memorize at one go. Okay, but later you'll see, okay, when we practice, okay, it will be much easier. All right, so we have completed the first half of the metals topic. Right, so for the subsequent lesson, okay, please finish this worksheet. Okay, and as I've said, okay, during the first part, okay, right, you will need to deduce the order of reactivity from a given set of experimental results. Okay, you can actually look at the last question of the worksheet. Okay, this is what I mean. Okay, when this is an experiment, okay, where they're adding metals, okay, to metal oxides, and then you can see, okay, some has reaction, some has no reaction. Okay, and we have this copper, iron, magnesium and zinc. Okay, actually without this experiment also, I can already arrange these metals in the order of reactivity. Okay, because I memorized the mnemonic. Okay, Popeye sailor can make a zoo in the land having killed one gorilla. So it will be magnesium, iron, zinc, followed by copper. Okay, but okay, if you don't memorize the mnemonic also, you can deduce from the experimental results. As you can see, copper, okay, do not react, okay, with the three of them. Okay, iron, okay, only reacts with copper oxide, but not these two. Magnesium can react with three of them. Zinc can react with two, but not one. So from here, you can see magnesium is the most reactive, followed by zinc, then iron, then copper. Yeah, so that's what I mean by deducing the reactivity of the series, the reactivity series of metals, okay, based on experiment. All right, okay. So all the best. Okay, I'll see you guys next year. Okay, bye bye.